Hello everyone. Uh, this is Harish Chodapurkar. I am the student of Harvard Extension School, and this is a case study part of my summer course Introduction to Deep Learning. And my case study is about the stock market analysis. So let me go through the contents. So I'll introduce you to why I chose the stock market case study, the objective of it, the data collection and pre-processing, feature engineering, and how did I and why did I apply these statistical methodologies pertaining to neural network, and how did the performance come out, and the next is how to run the code and the models, and then the technical details of the code, the final key points and observations, and the future score. So let's get started. So on the introduction, I would like to say the stock market is always the most fascinating and the ever interesting subject for the data science, and it's a phenomenal challenge for the data scientists given its volatility, given its movements, given its varied sentiments and market stuff, and also the government, foreign policies, debt ratio. I mean, we can keep talking about it. So let's so this project, basically what I'm trying to do is I'm trying to fetch the most commonly analyzed features for a moving daily stock price. So first things first, the stock fundamentals. This is the basic info about the company, and what's their market cap, the P ratio, what about the volume of the shares, and so on and so forth, the book value and stuff. So the next thing is the stock technical details, which includes what price the stock opened, what it closed, the moving averages, the volume, and all that stuff. And then the analyst recommendations from various financial institutions, whether it is a good, bad, or not so good buy at this time, and so on. And then we have general news, which definitely impacts the stock market, and and the next thing is the market sentiment, which generally is given can be taken by the industrial, the index funds like Dow Jones or S&P. And obviously the company news matters the most when in the moving stock market. So why are we doing this project? Basically to get rich, obviously. So fun apart, what I would like to say is the financial analysts spend a lot of time in analyzing the charts, analyzing the price, analyzing core things of the company, how it is moving, investor relations, and upcoming projects, and so on and so forth. But what we would like to do is we'll grab the most commonly analyzed features. In this project, I've considered mainly the technical details, the moving averages, market sentiments, and the news and analyst rating, the sentiments from the news and analyst ratings. So data collection, cleansing, and pre-processing. What did I do here? I've spent most of my time understanding from where to get the data. So I had a lot of options and I was confused. So we have abundant financial portals or gateways where you can access the daily stock data, which are pretty flexible. There are some free ones and there are some paid ones. So I chose the Yahoo API, which kind of suited the most for me in this project. The daily stock data is coming from Yahoo API. The stock analyst rating and recommendations is also coming from the Yahoo API. And since I couldn't get the news APIs to work well, I had to depend on the Kaggle project, which kind of closely helped me get the latest news from the market. And there are 3 different news sources here. So I took all this data and then finally I condensed it, cleansed it, and then came up with a stock master, which is a combination of all these three in a very simplified way, and the way which the our model can understand. On top of the stock market news, we have applied the NLP to get the sentiments and as positive, negative, or neutral. So this dataset contains 2 years worth of data, August 2018 to July 2020, to keep it crisp and short and making more sense on the latest and greatest data. So let's move on. On the feature engineering side, since I've already pre-decided what I'm gonna choose for this project, I did not really use a grid CV or any automated methodology to find the highest predictor power. I did go with this one. I did choose some of those, but basically I am dependent on what I already spoke about, the stock technical details and the market movement, analyst recommendations, and the news. So the next thing is created functions and all that stuff that I'm gonna speak more in the later slides. So what statistical methodologies we can apply here? So as part of deep learning, the stock market prediction best suits for a time series problem, and the deep recurrent neural networks is the best one to solve the time series problems. So as part of my initial model building and testing testing the stock variations based on these models, trying to learn the data and then fit the model, I tried the simple RNNs, LSTMs, GRUs, and combination of these have been analyzed to get the best fit out of the RNNs, available RNNs. So after running like some 300-400 combinations, I came up with 4 models which kind of performed really well against this data: the LSTM only, the GRU only, the mixed model, and finally the complex model with more hidden layers and stuff. So I did try all of these with various numbers of hidden layers, neurons, learning rates, so on and so forth, all the various model parameters. So whatever is available as part of the final coding is the good ones which I have experienced with this data. So how are these models performing? The performance evaluation is one of the most important criteria for choosing the model. So I did compare the loss between the training and the validation. So how much are we losing, how much are we deviating from the actual predictions. So this is one of the good ones, not great ones, but this is one of the good ones. This is a sample one. Maybe while I am implementing this LSTM and the GRU combination, so we have a sample chart as well here. So this slide explains you how to run this project. So I have simplified all my work in 4 different steps, and the step 1 explains how to get the data from the stock daily data and the analyst rating from using the Yahoo APIs. The second one uses the Kaggle dataset and applies the natural language processing for the market news available on the available from the Kaggle dataset. So based on this, we derive the market sentiments and store it in the CSVs. So the third one here, this is to merge the data what we got from the step 1 and step 2. All the data, the output files, the CSV files, we are taking it from the step 1 and step 2, bringing it into the step 3, and then processing them and condensing them into a single master file, a stock master file. So this step involves like bringing, say, the news generally is available for more than like over the weekends. Even the analyst ratings are also available over the weekend. So I'm trying to join the analyst rating and the stock with the stock available data. So if the news is on the weekend, there is no stock data available for the weekend. So I had to move some of these dates manually in the sense automatically from the news or also the analyst ratings to make sure that they apply properly, fit properly in the stock market data. And so just to note, the step 4 is the crucial step here. This is where we are preparing the data and to run the models. We are creating the stepwise data, and then we are building the model, and then finally doing the predictions and plotting the predictions versus the training versus the actual, and also the future prediction. So the last two, the discovery ones, so I have spent a lot of time to get all these stock data, so I added those two as well here, just to make sure that everyone gets access to this. So this also depends on a file called the ticker.csv, which contains all the tickers from the NASDAQ and the NYSE, and the output of this Jupyter notebooks would be the entire stock data and the entire stock recommendations for all tickers available for NYSE and the NASDAQ. So please note here that if you don't have to pre-process and run all the 1, 2, 3 steps, but you can directly run if you're interested in only the modeling part and prepping for the model. So you can consume the select tickers and the select masters with the new column on the column side, and run the Jupyter notebook so that you can get the entire predictions here. So I will stop this video here, and I will run through the code in the next one. Thank you for listening.